Hello everyone, this is ECE100, Introduction to Electrical Engineering. In this course, we basically learn about basic circuit theory and also how to put this knowledge together to make two devices that could be useful for our society. So let's introduce the course here. So this course basically a 2 credit 14 weeks course. Out of 14 weeks, as you can see that the first week we're gonna discuss about electricity basics starting from today. Then we're gonna discuss about DC circuit components for 1 week. And then we're gonna talk about the main theoretical analysis or circuit analysis of this course is basically the circuit analysis and introduction to capacitor inductors. That will take 6 weeks. Then we have 2 projects. As I said, we're going to try to put the knowledge together to build something useful. That will be project 1 and project 2. Project 1 is 2 weeks. Project 2 is 4 weeks. Project 1 is highly guided. And project 2 is basically open-ended. And I want to see your creativity, your imagination into that project. With doing this, we're also learning in parallel equipment and developing our skills. So we're going to learn how to use multimeter, power supplies, function generators, oscilloscopes, and also use how to use breadboards. And doing all those things, also developing our skills to build circuit and test them, and how to do troubleshooting when something goes wrong. So we're going to talk about this in the class, the brainstorming activity. Let's see. The first thing is what is electrical charge carriers? So charge carriers is the things that moves through the conductor or even doesn't move. Doesn't matter. Charge carriers are charge carriers. So in electricity, we basically the fundamental of electricity is electrons. So electron is the charge carrier. One electron is negative 1.6 10 to the power negative 19 coulombs. So that's the 1 unit charge of electron. Electron is negative, thus I have a negative sign in there. And what is the current? Current is the rate of flow of charges at a particular point. So if you look at a particular point of a conductor and see how many charges passing through that point per unit time, that is the current. So current is basically coulombs over seconds. So that's your current. And what is the voltage? Voltage is the potential difference between 2 points. It's a potential difference between 2 points in a circuit. So, and we call this volts. So volt is basically potential difference between 2 points in a circuit. Is for a unit for the volts is joules per coulomb. All right. So then, how do you know it? If you have a battery, let's say you have a 6 volts battery over here, then you connect it to a device. So that difference between these 2 points also 6 volts because we have a supplied 6 volt batteries here. Assuming that there is no voltage losses in the wire, that means wires are ideal. So energy is the ability to do work. The unit for energy, we have joules, and we also can have watt hour. Both are unit for the energy. What is the power? Power is the rate of change of energy. That means energy over time will give you the power. So energy over time give you the power. So that means you have joules over second will give you the power. The unit per power is watt. All right. So let's try to put it together here. So we have voltage, current, and power all together. Let's see. So power, we use the letter P for the power, and voltage for V, and current is I. So if I go here, voltage is joules per coulombs, and then you have your current is coulomb over seconds. If we cancel that, I have what? Joules over second. That's basically your watt. So it came together, right? So that's basically what that came together. So that's the voltage, current, and power relationship in the circuit. So then we have a conductor. So conductor is basically a materials that allow the almost free flow of charges. So mostly allow free flow of charges. So what are they? Like any metals, like your copper, aluminum, or let's say gold, platinum. Those are all conductor. Insulator. Insulator are the opposite side of it. They don't want to allow any charges going through them. So mostly block the flow of charges. All right. So what are the insulator? Like your glasses, rubber, wood, or your ceramic. Those are all the example of insulator. Resistor. Resistor, any device with a fixed amount of resistance. Any device with a fixed amount of resistance is called resistor. So resistor has a fixed amount of resistance. Resistance has the unit of ohms. So if I have 100 ohms, that means that device has 100 ohm resistance. If I have 100 kilo ohm, that means that device has 100 kilo ohm of resistance. And as you know, the resistance is the R is rho L over A. So rho is the resistivity, L is the length, A is the area of the conductor. So if I have a conductor here, let's say that I have a conductor over here. So this is the length of the conductor, right? And this is the area of the cross-section area of the conductor. And the rho is the resistivity of the conductor, which is the property of the conductors. That will give you the resistance of the conductor, which is R. All right, so and the device, if this device has 100 ohm of resistance, that we call that a resistor of 100 ohms. Then your semiconductor. Semiconductor is between the conductor and the insulator. That means the semiconductor is not conductor, is not insulator, is in between them. So it's in between Semiconductor has a unique property, like conductor resistors, they have a fixed resistance. But semiconductor doesn't have a fixed resistance. The resistance depends on the applied voltage and current. So the resistance of the semiconductor could change with the applied voltage and current. What are the example of semiconductor? We can have silicon, we have germanium. Those are the example of semiconductor. Then another important thing in the circuit is the ground. What is electric ground? Electric ground, there are different definitions of that. One is ability to zero voltage. That means if you ground some point, that voltage should be zero at that point. Number two, let's say reference point in the circuit. Reference in the circuit. That means you have a circuit. We say that this is the reference point. That means we're assuming that that point is zero. Then number three is the zero voltage. This is basically earth ground. So earth has always zero voltage because nothing can disturb the potential of the earth. So that we call earth as a zero ground. And that's all for today. I hope that you will review this and come to class prepared so we can do some problem and discuss some other things. With that, I'm going to end here. I'm going to see you for class 2.